Assalamualaikum warahmatullahi wabarakatuh. The Honorable, the examiners, good morning. First of all, let me introduce my name Muhammad Daffa, Afif Ramadan Tausa, NRP 0617040058, Design and Manufacture Engineering Study Program. I would like to thank for the opportunities that has given to me to present my proposal with the title Analysis of Fermentation in Fiber Composition and Alkaline Treatment of Composite Tensile Strands with Water Hyacinth Fiber. Table of Content. Chapter 1, Background, Research Problem, Research Objective, Research Significance, Research Delimitation. Chapter 2, Review of Related Literature. Chapter 3, Flowchart, Tools and Material, Research Metric, Research Schedule, Reference. Chapter 4, Result and Discussion. Chapter 1, The Background. The background of my research is because Indonesia is one of the island countries that 2/3 of its territory is surrounded by oceans. So Indonesia has a lot of river. That river is a water resource and can also help the life of the communities around the river. There are several plants that live in river ecosystem, namely lotus, water hyacinth, water kale, watercress, and bamboo. Water hyacinth is one of the weed plants in the water that live floating in the water. Water hyacinth has a very rapid breeding, so that this plant is considered as a plant that damages the environment. When the proliferation of water hyacinth cannot be controlled, ultimately will appear a very detrimental negative impact on the ecosystem in the river, that is the lack of sunlight entering the water, so that it can lead to a decrease in the level of solubility of oxygen in the water. The swallowing of the river caused by the death of water hyacinth plant, and also difficult for fishermen who will go to work or go home after work. The level of water hyacinth is not yet comparable to the growth rate. If the water hyacinth is processed properly and correctly, will provide added value. An example of one of the utilization of water hyacinth as a composite manufacturing fiber. So far, the development of composite in Indonesia is still triggered by non-renewable natural resource material such as glass, carbon, armid. Therefore, it is necessary to develop raw material for environmentally friendly composite materials, such as natural fiber. The use of natural fiber as a composite has many advantages. Such a fiber raw material are easy to obtain and easy to update. For example, water hyacinth fiber composite material are very potential to see in terms of the availability of raw material are very abundant, easy to obtain, low price, and non-toxic. In the description, there is the idea to do composite research with water hyacinth fiber and the manufacture of prototype recipe. Research problem. First, how is the analysis of fermentation in fiber composition to the mechanical properties of composite water hyacinth fibers? Second, how is the analysis of fermentation in the concentration of alkaline treatment in the process of composite mechanical properties of water hyacinth fiber? Research objective. First, able to analyze the fermentation of fiber composition to the mechanical properties of composite water hyacinth fiber. Second, able to analyze the fermentation of alkaline treatment concentration in the process of composite mechanical properties of water hyacinth fibers. Research significance. First, can be a reference and information in the research of natural fiber from water resin. Second, provide general information about the utilization of natural fiber as a substitute for composite material from earth excavation. Third, utilizing abundant and untapped natural resources. Research delimitation. 1. The type of water resin used is water resin from Kalimalang River, Kantong Village, Blaga, Lamongan. 2. Delignification process using NaOH with concentration of 0% and 5% for 2 hours. 3. Matrix tape use is epoxy. 4. Composite of fiber and material use 30% to 50 to 70%, 40% to 60%, 50% to 50%. Composite manufacturing. 5. Composite manufacturing technique used is hand layup. 6. Mechanical testing performed is tensile test. For 8. Fiber diameter is considered uniform by 0.5 mm. Chapter 2. Review of related literature. Composite. Composite is a material composed of two or more main materials where the properties of each material differ from each other. In order to obtain better mechanical properties, composites have better mechanical properties than metal. Young modulus or density and are higher in strength than metal. Composites are formed two different types of material, namely reinforcement and matrix. Reinforcement serves as an amplifier or main part that withstand load, has less ductile properties but is a more rigid and stronger. Reinforcement can use fiber or powder. Matrix. Matrix is composite material that act as an reinforcement binder. So the small strength of composite material depends on the strength of the forming matrix. This matrix has liquid properties with low viscosity, which will harden after the polymerization process. Delignification. Delignification is a process of removal of lignin in fiber material, so that the result of this process is in the form of cellulose with a considerable purity. Water resin fiber. Water resin is one of the weed plants in the water that live floating in the water. Water resin has a very rapid breeding. Both vegetatively and kinetically, water resin fiber as a composite material of natural fiber is very potential. To see in terms of the availability of raw material are very abundant, easy obtained, low price, and non-toxic. Tensile test. Tensile test is a method used on a material of determine the ductility and toughness of a material or material is by applying a force load or tensile stress to the material. Standard tensile testing refers to ISTM. Chapter 3. Flowchart. First, prepare the tools and material, then make the mold, then do the process of delignification of fiber with an NaOH concentration of 0% and 5% for 2 hours. Next, do the preparation of manufacture of composite with a fraction of volume of 30% to 70%, 40% to 60%, and 50% to 50%. After that is done tensile testing, and then processing the result of testing and data analysis, then compile a conclusion, then with a race prototype. Tool and material: screen or mold, basin, spatula, digital balance sheet, scissors and cutter, measuring cylinder, tensile testing mechanic machine, water resin vapor, NaOH, H2O, resin, and hardener. Research metric. This is a metric of research in which between variation in composition and variation of the lignification. The specimen taken in this table are 6, and each specimen repeats 3 times to obtain a consistent and optimal value, for a total of specimen is 18 specimen. Research schedule. First, preparation of tool and materials carried out in February to March. 2. Vapor processing is carried out in March to April. 3. Composite making is done in April to May. 4. Tensile testing is carried out in May to June. 5. Analysis and calculation carried out in the month of May to June. 6. The manufacture of race boat is carried out from June to July. 7. Preparation of reports and conclusion carried out in May to July. Chapter 4. Result and discussion. The result and discussion of this research is the calculation of material requirement for composite and the result of the tensile test that has been carried out, so that later it can be seen which composition and variation has the highest tensile strength. Reference. This is some reference from this research. The Honorable Examiners, I have presented all the content of my proposal from chapter 1 until chapter 4. That's all about my presentation. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.